Okay, back with the second video for the rest of this study guide. Number 5 says Gina, Terry, and Marvin are reading books. They all start with the same number of books read. The graph shows Gina's data. Terry is reading books at a rate of 3 books per month. Explain who has the greater rate of change. So I'm going to kind of highlight some important parts to this. They all start with the same number of books read. That's something that we're going to use. Let me just underline that. All right. They all start with the same number of books read. That is important. The graph shows Gina's data. You can see that Gina, her name is right here. So that is important to note. Terry's reading books at a rate of 3 books per month. So this books per month, that's going to be Terry's slope, which is the rate of change. So we're going to find both of those. 3 books per month. I'm just going to put a 3. To find Gina's information, we need to find the rise over the run. Which I'm going to put some crosshairs here. Honestly, it looks like this thing is pretty consistent. So that'll work. You can pick any of those. You can keep making dots if you want. I'm just going to keep it here. It looks like we're going up 1 over 1. So our rise is 1. Our run is also 1, which means our slope, our slope is going to be 1. So Gina's rate of change is 1 book per month. Who has the greater rate of change? Terry would, because 3 is more than 1. The number of books that Marvin has read per month is between Gina's and Terry's. So between 1 and 3, it would make sense that 2 is Marvin's rate of change, 2 books per month. And then since, and I underlined this up at the top, it says they all start with the same number of books read. That information is going to be found in Gina's graph. So the starting, that's the y-intercept. And in this case, we are starting at 2 books read initially by each of these students. Okay, so that one would work. Next question, graph the linear system. So just graph these lines and see where they cross. Do your best. It's probably because my pen is terrible. It's probably going to, looks like it's broken. Oh well. It's probably going to take me a couple times to draw the right lines, but just bear with me. So the y-intercept is 6. The slope would be -2 over 1. So I'm going to go down 2, right 1. And I'll do that a couple times. And hopefully I can draw me a good looking line here. And move it. That'll work. All right, so that's the first equation. The second equation starts at -1 for the y-intercept, and it gives us a fraction, which is always nice because that tells us the rise and the run, so that's up 1, 2, 3 over 2. Conveniently enough, it goes through one of the points that I've already graphed. Still need to make the line, but it should look like that. Well, oh, that's annoying. Oh well. Yeah, so your solution here is going to be at that intersection point of 2, 2. In class today, I did the check. I'm not going to do that just for the sake of time, but you can if you want to check and make sure that everything's fine. Number 7, describe what a graph would look like if the linear system has infinitely many solutions. That's IMS. That's going to be the same line, so it will look like, how about this? It will look like one line. Both, or I guess the equations would have the same slope and y-intercepts. Right? The rest of these are, excuse me, identifying if these are going to be functions. So does each input have exactly one output? That's what we're looking for. So is this one a function? Yes, this is a function. I'm going to say each input has exactly one output. Or each input is different. That would work as well. I know that this -8 might get you to question something, but keep in mind that's an output. And the outputs don't really matter. On this next one, is this a function? No, this is not a function because we have two inputs of 4. So I'm going to say the input 4 has multiple outputs. And those outputs are -1 and -3. And again, just tell me that it's not a function because not all inputs have exactly one output. That's all I need. Number 10, is this a function? Yes, it is. The reason that this is a function is because it passes the vertical line test. My pen has had enough for today, it seems. But it's only going to cross each point on this graph one time. If it crossed more than once, it would not be a function. But yes, the graph passes the vertical line test. And then this last one here, it says the independent variable represents the months of the year, and the dependent variable represents the amount of rainfall each month. This was similar to one. This problem is similar to the question on the first study guide. The months of the year are not going to repeat, at least in a calendar year. So that's how I'm interpreting this. So just for example, if I made a quick little table, and you don't have to, but and I'm not going to use all of the months, but January, February, March, April, May, it's going to go all the way up to December. Those numbers, those inputs are not going to repeat. So I don't know, 3 inches, 5 inches, 6 inches, 10 inches, whatever. They're not going to repeat. So yeah, this is going to be a function. And this is going to be a function for the simple fact of what a function is. Each input has exactly one output. And that is the second study guide. All right, make sure you get prepared for tomorrow's test, and I will see you then.